science education history. So a lot of what I'm doing today deals with that. There's a couple of other areas I've researched as well, and you'll see it kind of all flows in here. It's really a very interesting and rich history, as it turns out. We're going to cover things like the College Board, how they got formed. We're going to cover this thing called the Carnegie Unit, how that got formed. We're going to figure out how comes lab work came in, and I just thought I'd start you out with a little quiz question, which was in the reading that Brian gave you. What's this? This is the American Chemical Society symbol. It's a very interesting symbol, as it turns out. So what's that little strange symbol in the middle? I ask this, and everybody's looking now. I ask this, I go to chemistry meetings of chemistry professors, and nobody knows, interestingly enough, what that thing is. And it's actually part of what we're going to talk about today. It's actually from the German, it's called a Kaliar-Apparat. It comes from Justus von Liebig in Germany. Why is it in the American Chemical Society symbol? And how comes nobody ever knows anything about it? So part of the talk I'm going to give today is going to go through those sort of things. How comes things ended up this way? Very brief start. Lab work is like universal in the United States, in high schools. It's a requirement in New York State. You have to complete 1,200 minutes of lab work before you can even enter the Regents exams. This is a position statement from the NSTA on it. I'm not going to spend too much time on that, but it's basically saying you should be doing labs. That's the New York requirement. I know we're in New Jersey, but New York, you can't even take the exam if you haven't finished the 1,200 minutes of lab work and kept them on record. Where did that come from? Well, we're going to find out. So, I'm going to give you an advance. This is where we're going. We're going to look at the importance of it. We're going to trace it back to Germany. All of this comes from Germany, believe it or not. We're going to look at the different types of lab carried out. We're going to look at how in 1880 there was no lab work. By 1900 it was universal. What happened? Why did it become so important? And then we're going to look at this very strange concept. In America, you give 3 credits for a lecture, 1 credit for the lab, even though the National Science Education Standards say you should be doing lab work and inquiry-based work. So how comes lab is valued differently from lecture? In fact, much less than lecture. Where did that come from? We're going to answer all of these. Data sources, because I know this is a research methods class, you have to have data sources. I'm going to use a lot of primary research literature. These are studies that were conducted, surveys that were conducted in the 1880s. Committee of 10 report, Committee on College Entrance report. There are lots of sort of big committee meetings around the turn of the century. The New York Regents, how they were set up. They were one of the first ones to do some of these things. And then there's a whole host of wonderful secondary sources. If you ever want to read some great stuff, Rosen is a really wonderful author of things that nobody ever reads, which are really quite interesting, and a whole bunch of other ones. I put them into little categories. I'll give Brian the PowerPoint. You can research at your leisure, or you can contact me if you want to know any more. These are all the sort of who's who in the field. You'll notice earth science is in fact missing because earth science was in fact missing. But I've got to point out, in New York, more kids take earth science than physics and chemistry combined today. So that's really quite interesting. I will try and bring that one in where it disappeared in. So what comes out of this guy? Justus von Liebig. Very interesting character. He was a chemist at the University of Gießen, and that's when he worked there. He's called the father of organic chemistry. There are lots of fathers of chemistry, believe it or not. In England, it's Dalton. In France, it was Lavoisier. In Germany, it's Liebig. So each country has its own father of chemistry. If you're in America, it probably would be a guy called Alexander Smith. But what did he do? He set up a highly successful research lab, and over his career, he trained 700 students. There is an article in the Journal of Chemed that follows all of the genealogy of Liebig's students, which includes some 42 Nobel laureates in chemistry. So it's he's gone pretty widely. And he's really credited as being the initiator of the lab method. I'm going to tell you a little bit about it. He was pretty well known. he invented this thing. This is called the Calliar apparatus, and that's the symbol on the American Chemical Society thing. It's a simple piece of apparatus. All it is a glass tube with some bubbles on it, bent, and you put chemicals in here, sodium hydroxide, and what else? A couple of other things. And basically, it's a simple apparatus for doing organic analyses fairly rapidly. So in the 19th century, it was very difficult to actually analyze materials, chemicals, and Liebig just invented this very simple way. It gives you an approximate accuracy of about 1%, so you could figure out the formulas of all these things. Revolutionized the field, as it turned out. So you could do these. So what you'd do is you'd take the organic material, you'd burn it, and you'd pass it through here, and it would absorb the carbon dioxide and the water, and it'd give you some indicator of what the actual material you were looking at was made of. It allowed them to do lots of things and analyze lots of things. And he set up this journal. They were getting out 30 publications a year, 200 publications in total. His students were publishing all this work because they were analysing materials that nobody had really analysed before, as it turns out. So it's a very important piece of apparatus. So important that it actually makes its way onto the American Chemical Society symbol. That's what his lab looks like. You can actually go to Gießen and see it. It's a little cloudy. He trained a lot of things. He trained academics. He also trained pharmacists, and he trained people who were going to work in agriculture as well. So he was very practical as well as being an academic. Lots of people travelled there to study with him, Europeans and Americans, and I'm going to look a bit more about the Americans. I had this rigorous scaffolded training. They were very kind here. If you were going to go and study with Liebig in Germany, they allowed you 1 week in which they would speak English to you. After the 1 week, instruction was in German. So you had 1 week of speaking English, that's it, in German. If you actually look at all of the entrance requirements for a lot of the major universities in the United States, particularly the Ivies, you'll see they have a requirement of German. That's why. If you're going to be a chemist, all of the original research literature was in German. So if you didn't speak German, you weren't going to do particularly well. So they allowed you to do that. Basically, he set you this. They had this thing called the 100 bottles. You arrived at the lab, you had 100 bottles there with different chemicals in, and you had to learn all the techniques to analyze these bottles. It was called. Eventually, they moved it to down to 26, and it was called the alphabet of bottles. But that was it. You were given the textbook. You were given the 100 bottles, and off you go. And once you got through that 100 bottles, you were designated as being capable of doing research, and then Liebig condescended to work with you personally. Before you could get through there, that didn't happen. And that's basically it. So he'd have you in the lab. Notice it straight away, it's hands-on stuff. It wasn't you're going to learn this from a book. It was you had to actually go through this. You had to struggle, and it worked pretty well because people obviously wanted you to do this. Yep.
Well, you said it was scaffolding. How scaffolding?
I mean, they used to, the lab, Liebig had a lab instructor there who would help if you got really stuck, but otherwise, it was not scaffolded at all. You used the book, and you used the things, and you had to work it out yourself. That was it. And then once you got through those, you then were given a project, you're probably using the Calliar apparatus, to write some research project and do an analysis. So, it worked. People were really devoted to this guy. Many students, US students, actually went to study at Gießen. Really quite interesting is the fact that you couldn't really do graduate study in chemistry at the time over here. Simply, the universities didn't have chemistry departments, as you're going to see. So you actually went over to Germany usually. You could also go to France. You could go to England because they did lots of things there. But Germany was by far the most important one. So a lot of people go over there, and I'm just going to point these out. These are 5 people that actually studied with Liebig: Horsford, Gibbs, Smith, Ghent, and Porter. Harvard, Princeton, Yale. 2 others, I can't remember which they are. Right? These are all the people that set up the actual chemistry labs, etc., at the major Ivy League universities. So, and they all went over there to study. I'm going to concentrate mainly on Horsford, because he actually sets up the labs at Kean, at Harvard, and Harvard has the biggest influence, as it turns out, as you'll see. So Horsford goes and studies with Liebig. Once he's finished that, he gets the job. Things have changed. He goes to study with Liebig, he comes back and he gets the job as the Rumsford Professor of Science at Harvard. Now Harvard at the time doesn't have a chemistry lab. And a guy called Cook is actually teaching chemistry at Harvard, and they've given him a building on the outskirts of the university, and it's in the basement, and there's no running water. That's basically it. That's what happened to scientists at the time. It was a really classics-dominated university sort of system. And just to make matters worse, they had to actually buy their own chemicals and equipment. And how did they afford this? Well, they used to charge the students to learn from them. So that's basically how it worked. But Horsford, he goes over there, he sets up the chemistry there, and he convinces this guy called Lawrence, and it's still called the Lawrence Scientific School, to give $50,000, and they build a building there, and they set up labs there. And in that lab, and I'm going to make a little bit of it always amazes me, nobody knows who this guy is. You've all read your homework though. Who is that? And why is he important? It's not Cook. Good try. It's Elliot. All right, let me tell you a little bit about Elliot before I go through the slides. Elliot is the president of Harvard. He's the president of Harvard for 40 years. He's the guy that invents collecting money from alums. He's the guy that invents associate professors. He's the guy that invents written exams, etc., etc. The guy that insists that lab work be done. He's the guy that actually gets sciences into the classical curriculum. So he's a really quite important guy, as it turns out. And he's there for 40 years. He has a massive influence. But how does he start out? Well, he actually goes to Harvard as an undergrad, and he studies with Cook, who works with Horsford, and he's fortunate in that Cook set up his lab, and he's doing the labs with Cook. It's not an official course, he does it on the side, but he's really convinced that the way to learn chemistry and science is by doing labs, and that's what Elliot actually does at Harvard. And you'll notice what happens then when he graduates is he actually, unlike today, he becomes an instructor and then an assistant professor at Harvard. He's actually the assistant professor of chemistry and mathematics at the time. Eventually he takes over Horsford's class and becomes appointed as the dean. So, moving along a little bit. As fate would have it, Horsford resigns, or he earns enough money from all his little ventures on the side, baking powder particularly. He gets enough money to retire, and he retires, so the Rumsford chair becomes available, and of course Elliot thinks, I'm the professor here, I should get the job. But Harvard decides not to give him the job. It gives it to another very famous chemist, Gibbs. And Elliot's sort of a bit bent out of shape, so what he does was, like what everybody would normally do, you just lost your job, so he spends 2 years travelling abroad to Europe, Poor guy. But he leaves Harvard. He doesn't get the endowed chair, essentially, and he goes and visits Europe. And while he's visiting Europe, he kind of looks around at how the universities and things like that are organised. After he's been there for 2 years, this fledgling institution decides they want to set up labs. It's called MIT. And they entice Elliot to come back to set up the labs at MIT, and that's what he does. He comes back, he sets up the labs at MIT, and he actually writes the first ever lab manual, because Elliot is convinced that you can really only teach sciences by doing lab work. You've got to kind of train yourself, teach yourself. And that's what he does. He writes the first lab manual in English. All the other ones prior to that were in German or French. And that's what he does. It's an instant bestseller, by the way. And any of these books that I'm talking about, by the way, are freely available on Google Book, because they're outside copyright now. So you can get a copy of Elliot and Storer's wonderful first ever English lab manual. Have a look at it. It's very much like a cookbook, but it's revolutionary at the time. Now here's what's really strange, I think. So they entice him to come back to MIT. They've not let him become the Rumsford Professor of Chemistry, but 2 years later they appoint him as president. He becomes the president of Harvard. And it's really unusual because he's not a clergyman. He's actually a chemist. He's got a degree in chemistry, essentially. So it's really unusual. He's a great administrator. He changes everything in the university. As I said, he set up exams, he set up all these things. I'm just going to focus on the science stuff he did. He sets these new requirements. He says, hey, if you're coming to Harvard, you've got to have taken physics. Whoa. If you look at the 1870 requirements for just about every college in the United States, Greek, Latin, history, geography, so you know where all those things you're talking about in the classics are, and maybe a bit of arithmetic. That's it. No science whatsoever. Eliot says, Harvard, you've got to have physics to get in. So he makes this mandatory. And later on, about 10 years later, he says, not only should it be physics, it should be lab-based physics. Now imagine the impact of that on the schools. Harvard just said, you have to have physics to get in, so all schools are now offering physics, and we prefer lab-based physics, so all schools are building labs at a great clip. And for his part, Eliot gets Cook to write this thing called the pamphlet, and it seems like it's so long ago. This is, by the way, in the 1880s. And Hall, Edwin Hall, famous for the Hall effect, he writes the physics experiments. And to get into Harvard, you have to take, if you go in to get into Harvard, you have to take your lab book along. And Hall will actually test you if you're a physics student. He'll bring you there and he'll look at your book and he'll actually test you on all these sort of things. So it has a massive effect on whatever he's doing. These labs, by the way, are still taught. When you go into a school and you do the chem labs and the physics labs, they're often from these lists, believe it or not. And I'm going to show you a little bit about that. I'm going to gloss through this. If you're really interested in the period, Clark did a study in 1878. He looking at all the schools in the United States that he could get data from, which was most of them at the time. This is what they found. There were lots of different things, offerings in physics and chem. He could only find 4 schools that had a 1-year course in physics. Usually they were taught over 14 weeks. So they were short courses. And very few of them had lab work, because it was expensive. Textbook, recitation, lectures dominate. Now, what does recitation mean? You all in this American system, you all went to college, you all went to recitations. What does it mean?
Practice problems.
Practice problems, that's what it means now. That's not what it meant then. It meant exactly what it says.
Memorize and spit out.
Memorize and spit out. We're going to learn some earth science now, right? From an astronomy book from the 1880s. Okay, this is how you learned astronomy. Notice, if you were teaching astronomy in a school in the 1880s, it's very unlikely that you'd actually taken any astronomy. So you're teaching something you didn't know anything about. How could you do that? Fortunately, you had the book. And the book had all the answers in it, and you didn't actually have to know anything. So we're going to try you on this. All right? This is the answer to the question. It is called the Earth or World. I'm the teacher. So here's what I do. I set you your homework. It used to be called prep, by the way. That means I'm preparing you for tomorrow. Here's your homework. You've got to go away and read lesson 1. By read, I mean memorize. And then the next day you're going to come in and I'm going to ask you the questions, either as a class or individually, and you are going to stand up and recite the answer. And if you get it wrong, what's going to happen? We have this piece of wood that we might use. Right? Just as an incentive. Okay? So, let's try the first one. We'll do this as a class exercise. What is the body called upon which we live?
All the earth and the world.
Good job, you've learned it. No, that's where recitation comes from. There are lots of books, you can look them up in Google Books. Now, what is really interesting though is, how does that lead to the credit system? It used to take, to memorize lesson 1, twice as long to memorize it as it did to recite it. Twice as long to recite it. 3 credits. That's That's where it comes from. 1 credit for the class, 2 credits for going away and learning it. That's the fundamental basis of the 3 credit. If you figure, why is it 3 credits? Doesn't make a lot of sense. Well, there you go. And then they're going to tie it into the thing. But that's fundamentally where it comes from. Notice, how about lab work? Oh, you don't have to do any memorizing. You don't have to do anything outside class. Right? That's fundamentally where it's going to come from. Okay. Be brief on this one. I know there's no physicists in here, but it's really quite interesting. They were so concerned when the Clark study came out that physics, only 4 schools were really teaching it, that they said that can't be, and they commissioned another study, and it was done by this guy called Weed. They noticed in the Weed study that everybody was advocating for lab work, but nobody was actually doing it. It was, oh yeah, let's do lab work. And they suggest these 47 experiments. You'll notice this idea of a list of experiments comes out, and they advocate using the Gage book. If you want to look at an interesting book, Gage's Elements of Physics is really quite interesting from the turn of last century. It shows you how they were thinking about it then. And Gage is the guy that's supposed to have designed the first ever lab, as it turns out. I'll be brief on this one as well. This is Edwin Hall, famous for the Hall effect. Harvard's allowing lab work for admission, and Hall's given the opportunity to actually set up the lab, so he writes all the labs, and you'll be familiar with them, Ohm's law and all these type of things, and he writes this thing called the Harvard descriptive list. Okay, and that's what it is. I'm not going to worry too. It's a list of experiments including this, this, and this. You will recognize it if you were to see it because you've all been subjected to it. He actually personally supervised the exams, and they considered it the most important part. Physics teaching became specialized, widespread influence. I'm going to zip through this fairly quickly. Back down to Elliott again. So Harvard and these places have come up with this idea that to get in you need to have lab work, and you've got to keep a lab book and you've got to hand it in. Notice, we're a little bit before exams. The Regents exams have just been created. There's no SATs yet because they haven't been created. They're going to be created fairly soon. Most people aren't given exams. Each individual college has its own entrance exam to get in. They're going to have an influence here. Elliott recognises, well, this is silly. There are, 300 colleges. All of them have got their own different way of setting exams and things like that. So he actually uses his influence as the president of Harvard to get together this thing called the Committee of 10. Technically the most important committee in education that ever existed. It's going to set up what goes on in schools. It's going to have a really massive impact as it turns out. And it's chaired by Elliott. Surprise, surprise. You'll see Elliott appears in just about everything of major things at the time. It's very influential. In the sciences, they recommend half the time should be lab work. Right? Well, that's pretty good. They actually tell you what labs you're going to be doing. I've got to point out that the chemistry group is actually suggesting that they do lots of Elliott's labs as well. Surprise, surprise. Anybody recognize this character? This guy's called Ira Remsen. He was in charge of the chemistry subsection of the Committee of 10. And this is really where the sciences make their way into high school. Prior to this, it's the classics that dominate. After this, the sciences make their way in and they're on equal value to the classics. And this is the important thing. Lab work is the important thing. Because lab work meets this condition called mental discipline. Because the way they used to think you learned in the 1890s was that your brain was a muscle and you exercised it. And how did you exercise it? Memorization. And which subjects were good for memorization? Latin, Greek, mathematics. They were the best subjects for exercising your brain. The sciences were, what tradespeople did, so they weren't counting quite as much. But with lab work, they got this discipline. You had to observe nature. You had to write down meticulously what was happening, and that added this mental discipline view to it. So that's what they're advocating around the turn of the century. If I go into classes across the United States, I see it still in practice, mental discipline. Even though we don't believe in it anymore, it's still the modus operandi in a lot of schools. This is what the Committee of 10 recommended for science and math. Okay? Now, let me just translate briefly. Smart kids How can you tell they're smart? It's the classical one. It's the one that all the, Lawrencevilles and Harvard feeder schools are going to be taking. It's for the people who are going to be politicians and clergymen and leaders of things. It's got 3 foreign languages. You have to take 3 foreign languages in the classical mode. As you move this way, it becomes less rigorous. So look what they're recommending here. First year, algebra. Second, and physical geography. The equivalent of earth science appears there. Physics is in the 10th grade. Oh, the Committee of 10 recommended physics first. And they said, because before you leave school, you should have taken physics. It's that important. Geometry in there, then math, algebra 2 and geometry 2, and then chemistry in the 12th grade. Chemistry was a bit abstract. It was in the 12th grade class. What's missing? Biology is completely missing from the classical. Don't need to know any biology. What else is missing from the classical? Look at the math. I bet all of you did more. Where does it get to? Where's calculus? Oh, doesn't appear yet. Where's pre-calc? Hasn't appeared yet. This notion that math and physics go together. Notice they're saying physics in 10th grade and you don't have to have calculus, interestingly enough. Let's just move over here. This is the second one, the Latin scientific, only 2 languages, so they were going to let you off Greek here. You don't have to do Greek in this version. It follows the same pattern except what? What appears? Botany or zoology? Notice, biology does not exist. There is no biology. Biology does not exist as a subject until about 1907 through 1915. It's not a subject. There's botany, which is a different subject, and there's zoology, which is a different subject. The botanists and the zoologists, neither one of these groups wanted to be biology. They wanted to be botany or zoology. So in this committee, they argued we should have a year of botany or we should have a year of zoology, but we shouldn't combine the two. Ain't going to work, as it turns out, but that's what they're actually recommended. The rest of it is kind of the same, except notice there's some earth sciences in here. Geology or physiography appears in the 12th grade. Anatomy and physiology and hygiene. So, but of course it's of lesser value. This is taken by people who aren't going to be the leaders. It's just added to it. Astronomy and meteorology. So there's a lot of earth science actually recommended by the Committee of 10. So moving along. So the Committee of 10 makes these recommendations. The Committee on College Entrance Requirements, 5 years after it, is commissioned to implement these things. This is probably the most important committee that ever met. The Committee of 10 was really quite important, but the Committee on College Entrance Requirements did stuff that you are still doing today that nobody knows about. Right? And it's really quite interesting. So I'm going to tell you some of these wonderful things. So that's what they were there for. Hall was given the job of being in charge of the subcommittee on physics. Alexander Smith, in chemistry. Those of you who are chemists, you may look at a college chemistry book from like the 50s and the 60s. They were called Smith's College Chemistry. After this guy, notice that's 50 years after he actually published them. They're still calling it Smith's College Chemistry. It was that influential. As I pointed out in the last one, this thing has been really largely overlooked. What do they propose? This is revolutionary, and most people don't think this is, and I'm going to explain from a different situation here. They propose the credit system. Right? Now, you've got to understand, the United States is the country that has a credit system for its education. I did not graduate from high school because you don't graduate from high school elsewhere. You graduate from college, you don't graduate from high school. There's no proms. That's an American idea. There are no, how about this one? There are no transcripts. I do not have a high school transcript. There are no GPAs. I did not have a GPA. How do you get to college in Europe? Still to this day, there's no GPA. You pass the test, you go. You fail the test, you don't go. It's a real simple system. It's like a cliff. Once you fail the test, you go back and take it again. But that's it. You pass the test, whatever. This is where the college system, this is where America changes from a lot of the other places in the world. It invents this credit system. Let me just explain briefly what the credit system is, and I'm going to go into it in a bit more detail. 1-year courses for sciences. Right? You're all familiar with that. Now, I didn't have 1-year courses in sciences. I took chemistry 6th grade, 7th grade, 8th grade, 9th grade, 10th grade. Then, I majored in it in 11th and 12th grade. I took physics 7th, 8th, 9th, 10th, and majored in it in 11th and 12th. I'm only taking 3 courses in the 12th, 11th, 12th grade. Bio, I wasn't a biologist. Just 9th, 10th, 11th, right? That was it. So, this is an American thing, the fact you teach. So if I was to say, what's the most identifying feature of American science education? That's it. 1-year courses. So my question to you, why? And I'm going to point out, pick another country in the world. Anyone. France does not have 1-year courses. Pick another country.
Germany.
Does not have 1-year courses. You can't lose on this one, because they don't have, Philippines does, anything that's under the American, Liberia does, but otherwise they all teach the sciences over multiple years. Why is that? Well, this is why. The United States is big. Seems like a very simple answer, doesn't it? Therefore, its schools are very small. So if you went back 100 years, the average school was what size? 1-room schoolhouse, 50 kids. How many teachers? 2 or 1. Now, there's just no way on this planet you can have lab work and 1 teacher for all those subjects. So the only way you can do that is by having 1-year courses, and you alternate them, and that's exactly what happened. It's the size of the schools that determines the America. There was the debate, lots of debate. They wanted you to do more sciences. There's no way the schools could do it with only 2 teachers and 50 kids. So that's what they did. Anyway, so these are the guys that recommend this. They say, hey, it should be a 1-year course. Right? All courses should be 1-year courses. Right, what happens? Earth science disappears. One fell swoop. Astronomy is not a 1-year course. Geography sort of survives for a few years, but eventually goes out. Meteorology, not a 1-year course. Out it goes. Right? All of these courses, if it's not a 1-year course, it's gone. What's to botany and zoology? They combine. Otherwise, they would have gone. Right? And that one worked, as it turns out. But that's fundamentally what happened. Look what they recommended as well. So you've got all these 1-year courses now. You'll notice the graduation requirements in New Jersey and New York are somewhat different from the graduation requirements in, this is 1900 by the way, 1899 they came up with it. 4 languages. 4 languages, I'm not talking like English is a language. You have to do 4 years of language, like 3 years of Latin, 1 year of French or whatever, 2 years of English, 2 years of math, 1 year of history. New York's requirement now is 4. Historians somehow won out on this one. Nobody ever asked me why that happened. And 6 electives. They were really being quite smart about the electives. They knew you couldn't offer every science. So they said, we'll make them electives. But you're going to take, they just assumed all the science will be taken as electives. Didn't happen, as it turns out. 1 year of science, by the way, was the requirement. And they said, and if you're going to take one, and only one, it should be physics. Interestingly enough. Lab work had to be the norm. Physics should be taken before. So these guys were way ahead. The new movement in New Jersey is to move physics first, like Newark's starting to do that. 100 years ago, they actually recommended doing this. These guys had a massive impact. So after that, so they're making a 1-year requirement for science. So it's recommend 1 science college for college admission. Let's jump ahead to 1960. No, let's jump ahead to 1980. 1980. I was alive. I'd been teaching several years, in fact. 40 states still had a 1-year requirement for science. It was only after 1982 and Nation at Risk came out that all the states said, maybe we're not doing enough science to compete with Japan. So guess what? After that they increased the science requirements. But up to 1980, 1 or 0 year requirement from 40 of the states. Amazing, really. Here's what he said. I'm not going to read through all of this, though I've got to tell you a little bit at the bottom, which really I'm kind of find amusing. So they're saying you should do lab work. They're saying it should be a 1-year course. The physics group has a bit of a problem, though. I call it the secret shame. And this is the report. Poignant regret that the committee appointed by them couldn't do the job. The report on zoology came too late. That on physics was incomplete by lack of harmony. The physics group were made up of 12 people, 7 of whom had written textbooks. And they couldn't agree on what should be the curriculum for physics. And so they disagreed, and Hall, who was the chair, was so pissed, he actually sent in his list of experiments as the report from the committee. And that's going to be quite interesting because it gets adopted by a group. But the physics group can't agree. Have things changed? And he noticed, hey, they'd written textbooks, I couldn't get them to get any agreement. So that's what Hall does. He sends in the Harvard descriptive list as the thing. Now, why is that important? SAT. Remember the SATs? Well, they were invented when? 1901. Right? 1901 is the first college. They're not called the SATs then. They're called the College Examination Entrance Board. And why are they put together? Because all the different colleges have different entrance requirements, and they get together and figure, well, this is a bit silly. Why don't we do one board? And they did that, and it really is in the Northeast. It was Columbia University. They met in the library there, and they come up with this agreement in 1901, and they start doing this. 1901, physics and chem are the only ones given. Botany and zoology had handed in their reports late. Earth science has now conveniently disappeared altogether. It's not a college board thing. It's going to be killed for that very reason. And this is what they do. The college board adopts the Committee on College Entrance Requirements, syllabuses. So what's the physics syllabus? A list of experiments. That becomes the first college board physics syllabus is the list of experiments from Harvard. And it is that for the first 5 years, interestingly enough. Notice, a couple of things are different. Lab work is required. I'm going to give you one of the first college books. Fine, do you want to hand them out? Lab work required. They expected you to do 40 experiments. For the first college board achievement, you have to hand your lab book in. Right now it's all multiple choice, but they're going to hand the lab books in, and their examiners are going to mark them. Here's, I believe it's 1902, Brian, is it 1902?
Yes.
1902. This is the College Board, i.e. the SAT2 chemistry from 1902. I know there's a bunch of chemists here. I bet you can't pass it. It's changed. I'm just going to read a couple of things off here which are quite important and relevant to us. Answer 7 questions. In this exam, 30 counts will be based on the lab notebook. Whoa! They're giving you 30% of your exam on your notebook. It's great. They're just reinventing that, by the way. And 70 for the questions. 7 questions, 10 each. Whoa, that's a simple system. If you look at this, you'll find it's quite difficult to do. Why? Right, who are the chemists in here? Right, number 5. Suddenly gone quiet, Brian. What do you teach them in New Jersey? Not those things. It's completely different. Most of the 1902, by the way, the electron hasn't quite made it into the chemistry books because, hey, 1897 it was sort of discovered. The proton hasn't made it yet. It's not there. There's no acid-base theory. There's no bonding. Periodic table looks completely different. Right? There's no neutrons. They're not going to be around for another 30 years. It's completely different. Acid-base theories, Arrhenius, that was it. Larry Bronson doesn't come out for another 20 years. So completely different. It's all descriptive, by the way. It's all memorization. So you can do well if you memorize the book. Get hold of a chemistry book from 1900s. They're great. They're excellent reads. How to dissolve gold, how to do all these wonderful things. They're great. They're very good books. Anyway, so that's what happens. The College Board noticed the power of lab work. Right. Now, this part I found completely amazing. I was so shocked when I found this out that I was stunned. And I was even more stunned when I figured out nobody actually knew this either. This guy is called... We have a bit of a issue in how we say this. Carnegie or Carnegie. I call him Carnegie because he's Scottish and the place in Scotland is called Carnegie. And it's a famous golf course, as it turns out. Carnegie is the American version of it, whatever. What did he do in his life?
He made some money.
He made lots of money. How? Steel. Right? He made lots of money in the Industrial Revolution, and then he decided to give it away. Right? Which is good. So he actually, CFAT is the Carnegie Foundation for the Advancement of Teaching. He gives $10 million, and this is probably the best investment in education ever made. Right? And I'm biased here. He gives that $10 million to set up a pension fund for professors. Brilliant. Brilliant move. Why is it a brilliant move?
Yeah, it's like more people to the profession.
Well, he's a bit sneaky than that. This guy is, I mean, he isn't a billionaire, the equivalent of a billionaire in that age, without being very smart and clever. He really wants to make his money have a big impact. And he knows if he gives this money, there are strings attached to this money, right? There are going to be strings attached. So if the colleges who haven't got a pension fund for their professors want to buy into this, they've got to adopt the Carnegie system, right? And the Carnegie system has far-reaching impact, as we'll actually see. But that's what he does. He gives this $10 million. If you want the money, you've got to buy into the Carnegie system. So what does Carnegie actually say? He says, how do you know you're a college? It may seem pretty obvious to us. It's a college or a high school. Not so obvious around that time, because this is 1900, between 1900 and 1910, say. Some colleges had high schools which kind of morphed into the colleges. It wasn't really clear what a college was. So Carnegie says, this is what a college is. It's got to have a 4-year program, and it's got to have 6 full-time professors minimally. And if it doesn't meet that criteria, it's not a college. And the other thing he says, it must accept kids from schools that have had a 4-year high school course at least. Right? So in other words, you can't leave at the end of the 9th. This is what used to happen, by the way. Get to the end of the 9th grade, you could get to college. Nope. You have to have had 4-year preparatory work. And he defines what that is. It's called the Carnegie Unit. Anybody come across the Carnegie Unit? Have you got any Carnegie Units?
College credits.
Nope. Nearly. Oh, do you go to high school? What do you get? How do you get a diploma? And what do they give you at the end of the year? A credit. Now that's the Carnegie Unit. It's the Carnegie Unit you actually got. If you actually look at those, New York requires you to have 22 Carnegie Units to graduate. This is what he did. Here's a Carnegie Unit. It's very easy to illustrate. This is a chair. How do you get a Carnegie Unit? You sit in the chair. For how long? 120 hours. Let me translate that. That's 180 school days, 40-minute lesson. That's it. Doesn't matter what you learn, it's the amount of time you spend there. And he defines that. It's the Carnegie Unit. What's so interesting about this is, anybody, well, you may not know this, but what's the pension fund called now? TIA-CREF. It's the biggest pension fund in the world. All professors just about still use that. My pension is a TIA-CREF one based on this. our earth science friend left before I could ask him, but that's it. So Carnegie, he gives this 10 million. It's really quite important. He defines what a high school is. It's 4-year things, and he defines what a course is. It's 120 hours of seat time. Bing. It's still what goes on today. You get the credit for sitting in the thing, not for passing the actual tests themselves, and that's basically it. The whole American education system is stuck with this problem because all the colleges and high schools adopted the Carnegie system. He proposed it in 1905. It was adopted in 1909. Just about every school in the country and college was using it by 1911. It was instantly successful, powerful sort of thing. It was great. And we're still doing it. I would say, of all the things that ever happened in education in the United States, this was the most successful. Everybody bought on it. Why? Money. Money in education really does talk. We could change it. I'm going to make a suggestion about that later. It's the coin of the realm. It's so ingrained in the United States system that you can't think without the unit, right? But every other country in the world doesn't give credits, and they aren't based on the amount of time in a class, etc. They're based on how well you do in exams usually. It's universally adopted. Hey, we're stuck. We are still teaching exactly what we were doing in 1910. We've updated the curriculum, but the curricular time is still based upon the 1910 version. Why is that a problem for science? Chemistry particularly. Well, even more important. You're right, but even more important. What happened to chemistry this century? Last century, rather, and this century. Well, you started out the decade, the electron had just been discovered, there was no proton or neutron, there was no acid-base chemistry, there was no bonding, no electronegativity. The periodic table was completely different. There's no governing principles on it, there's no Lowry-Bronsted, there's no Lewis acids, there's no systematic naming of organic chemicals. All of this stuff got invented in the last century. I have a little illustration here. This is a bit of an old book. You've got to have a look at this book though. This is a chemistry book from the 1800s. Right? I will read you the title. You can have a look at it. It's called Chemical Recreations, a series of amusing and instructive experiments which may be performed with ease, safety, this is the title by the way, ease, safety, success and economy, to which the romance of chemistry, an inquiry into the fallacies of the prevailing theory of chemistry. That's the title of it. I'm just going to come round and show you this, because you might not believe me. This is the book. This is the chemistry book. And look at the illustration, right? Just have a quick look. The guy is dancing around with the romance of chemistry. See it all? Why is the guy dancing around with the romance of chemistry? Because he's just taken a whiff of nitrous oxide. I jest not. They're advocating that you try these things.
Hands-on, nose-on?
Hands-on chemistry. Well, nose-on chemistry. And there's some other wonderful things in here. If you look at the periodic table section, there isn't really much on it, and the elements have got different names, a lot of them. Look how big it is. Let's just advance 30 or 40 years, you might notice a change in the chemistry books. What do you notice is different? Bigger in every dimension. And the font is same size. Let's go another 40 years. What happened to chemistry? Oh. That's about 100 years. What happened? Well, more content. Why? Because, hey, a lot of chemistry was discovered, and there's nothing wrong with that. It makes a lot of sense. What happened to the curricular time? It's the same. 1 year, 120 hours, 180 minutes. We'll throw in this lab work. That's a double period once a week, and we'll only count it half its value. as we'll see. Oh. Well, you just have to be careful with chemistry books, they can be dangerous. They can kill you. Right, but that's what happened. The curricular time did not actually change. Right? Now note, I'm just going to, one illustration while I'm on it. Look at this. I mean, chemistry, the central science, there are 1,000 pages. I mean, 1 year. How many concepts how many concepts are in here? Lots, more than a foreign language, right? One new concept every 4 minutes for a whole year, as it turns out. And it's full of math, right? And it's completely unreadable. I mean, I can read this because I've already got a chemistry degree. Try to learn chemistry from this? Forget about it. Not a chance of that actually happening. Shall I show you an equivalent European book? Same course. You might notice a slight difference. And it's got experiments in it. I'm not going to beat up too much on chemistry, but if you have a look at this, you can start at the beginning and look for the first chemical reaction in the book. Where does it appear? Chapter 7, usually. So the first 6, and you probably know what's in the first 6. What is chemistry? Matter. Oh, you got it. Well, what comes next? What's at the end of that first chapter? Significant digits for experiments you haven't done yet, but let's put them in there just in case. And what else? Milli, micro, nano, pico. The metric system's in there. The gas law. It goes on and on and on. It goes subatomic before it actually goes. You'll notice this one starts out with chemicals, where you find them. Interesting. Chemicals from rocks. Chemicals from the land, chemicals from the sea, chemicals from plants. Completely different approach, right? So I'm not going to beat up on that. But the problem with the Carnegie unit is it defined everything. It's still there, and it defines everything. Everything you have to do fits in there. So APs, are we familiar with AP chemistry and AP bio and all those? When did they start? Yeah, but what year did they start? You're right. Well, not on Long Island, by the way. 9th and 10th grade. 1960s. Right? Early 60s, first APs appeared. Guess what? 1 year courses. Why? They've got to fit in with the system. Now, if you go to France, there's this thing called the French bac, 2 years. England, A-levels, 2 years. Gymnasiums, 2 years. Australia, 2 years. They're all 2 years. AP Physics, next year, 2 years. It's going to be a 2 year course, finally. But notice, everything fits into the system that was invented by Carnegie, as it turns out. Administratively, very sensible, works. So, I'm just going to go on the last thing. That's the problem with it. It fixes the course in place. It's problematic, though. This 120 hours was problematic. The scientists wanted a double period a week. That doesn't quite work with the 120 hours of 180 days at 40 minutes a time. So what do you think they did? The science teachers sold their souls. They said, we'll have a double period, but we'll only count it as a single period. And that's what they did. And I'm going to show you, it's written in black and white in the College Board thing. Here's the College Board Physics in 1909. Physics is 120 hours of 60 minutes. We adopted the Carnegie unit. Time spent in the lab should be counted at 1/2 its face value. So they said, you've got to do lab work, but it doesn't really count as much. Go figure. And then they're telling you what you should do. 30 lab period, 30 double periods a year. That's 1 a week, essentially. And you have to have 30 experiments on file still. That's still the requirement in New York. It's still 1,200 minutes of lab work. Let me translate that. That's 2,400 minutes actual time. Because we don't count lab work at the same value. It's only half the value. And just in case you were worried, slovenly work will not be tolerated. Okay. So, a few talking points. What's the point of doing these studies if you're not going to have some talking points, right? Time for high school physics and chem. The reason the United States doesn't do particularly well in the international math and science studies is, and the American Institute of Physics nailed this straight away, the counterparts in other countries have spent more time studying the subjects that you get tested on, so they do better. It's a no-brainer, you know? The person in England's done 5 years of physics, they're going to do better than an American student who may or may not have taken physics, and they only took 1 year of it. So, I'm going to suggest that this doesn't fit into 1 year anymore. Imagine trying to eat this in 1 year. I mean, it should have changed years ago. The United States doesn't teach any other subject that way. History, French, English, math are all taught over multiple years. French 1, French 2, French 3. Biochem physics. Doesn't make sense. So there's that one. Lecture lab dichotomy. I mean, does it make any sense to give lab work less credit? By the way, you're all chemistry majors, I presume, or science majors. You spent more time in college studying than anybody else, because your labs didn't count. You know? Well, we don't count. Well, learning French and speaking French doesn't count at the same rate as actually writing French. You know, that's the equivalent of what they're saying. So you probably noticed your roommates, etc., who were criminologists or social scientists or whatever, spent less time going to class than you did to get the degree. And it's getting worse, by the way. It's actually getting worse. More and more courses are appearing in that time period. You know, they're shoving more and more in. Here's my evidence, by the way. It's a bigger book, right? What happens in the other subjects? They have 2 courses. French 1, French 2, French 3. So if you actually want to do it, here's a good study you could do. New Jersey. Look at how many minutes in high school the kids spend in the subject before they take the exam. Which subject do you think has the least amount of time before you take the exam? Well, French is probably the most, i.e. you get 5 years of French before you take AP French. They're supposed to be the same, by the way, AP French and all other APs. How about English? You tried taking AP English in the 10th grade and then asking your school if they, well, I've passed AP, I've got college level, can I have the next 2 years off? No, it's a state requirement. How about history?
Our kids take AP in 10th grade, and then they still take it.
Then they still take it, because it's still required. Even though my son is a historian. He took 4 AP histories. He liked it. I mean, fair enough, he liked it, but it's like, hang on. But he didn't, why is he taking the sciences? Well, not required. So, many, multiple years, and he took US history about 4 times. 3rd grade, 7th grade, 9th grade, and 11th grade. I couldn't figure it out. It's the same course. Slightly more complicated, but... So, that's what's going on. These things actually do not actually fit in there. The lecture lab dichotomy, this is, you know, we should be awarding labs the same amount of work. You've got to get some sort of parity here. You know, it's getting worse and worse and worse as it turns out. And credit for physics and chem. The amount of stuff you do in chemistry, I'm going to suggest you should get, for completing AP Chem, 3 credits of high school. Not 1, as most places give you. 1 credit. You spend more time in the subject, so you can get through the massive curriculum, and you still only get the same credit. 1 year credit. Why? Because they're still using the Carnegie unit. Will this ever change? Yes, it's got to. Right. Questions? You must have some questions. I'm sure I've got to the end. Yes, I did. Whoa, look at that. No signal.
So, Carnegie, besides just wanting to, I don't know, hold dominion over these little college professors and high school teachers, was there a reason?
Yeah, he didn't want to hold dominion over him, and he wasn't just doing that. I just described the credits part of it. He also gave lots of money for libraries, I'm at an R1 university, that's a Carnegie designation. He designated those sort of things. Everything, he knew he'd have a big influence. He personally had nothing to do with it. He gave the 10 million, he appointed a guy to run the Carnegie Foundation, but he wanted to make the education system in the United States run along the same lines as his companies did, which were very efficient. They made lots of money and gave it to him. That's what he wanted. He wanted an efficient educational system based upon business lines.
So, being from Scotland, was he anti-Scottish education?
No, the Scottish education system is interestingly enough, most Americans that go overseas to study go to Scotland. It's sort of somewhat similar in ways. But even then, you still do multiple years of science. The sciences are the only ones that are actually different. And it wasn't called the Carnegie Unit, it's called the Unit of Instruction or something like that. It's just, the nickname is the Carnegie Unit. If you go to the National Centre for Educational Statistics and look at the transcript studies, or you go to any website of the state, they'll say, at the bottom in the things, a Carnegie Unit, and they'll tell you what it is. Different states, it's called the elastic meter stick. It's whatever you say it is. It says, imagine having a meter rule which is made of elastic. And look how long it is. It's a meter. Oh, it's a meter. It's always a meter. That's fundamentally what they do.
I'm assuming he meant well, and I'm sure he meant well.
He did. It was brilliant from an administrative perspective. He said the thing needs standardizing. There was just sort of randomness going on, and that was part of what he was trying to do. He was trying to make it more efficient. And he standardized high schools, he standardized colleges, he did a lot of standardization because he thought that would be good for it. Administratively, it was. It took all the chaos of all these different places, different states, local control, and it implemented this standardization on it. It's just a little too much. So suddenly, the principal of a high school could do a timetable on one piece of paper in an afternoon. When you go to a European country and try and get a timetable, it takes a committee of 10, 6 months to figure out the timetable for a school. Here, a principal could do it in an afternoon on one piece of paper. Why? Period 1, math. Period 2, and they're all single periods, 40 minutes, right? Period 2, French. Period 3, geography, whatever. That's how it, and then you rotate them around. That's it. Other places, like in England, all sciences are taught in double periods or triple periods. That doesn't fit very easily, so there's a lot of negotiating going on. I did all my high school chemistry in a lab. There was no lecture. It's all lab-based. So it's a different, completely different approach to it. So from an administrative perspective, it brought a lot of regimentation to a completely erratic type of system. So it was good from that perspective. And it was pretty good for the sciences initially, but they developed. Sciences are different from every other subject. I mean, half the stuff didn't exist. I mean, if you look at this chem book, you're not going to understand half of it. If you look at the chem on the 1902 regions, this is just before the Carnegie Unit came out. If I showed you a botany exam, you'd all fail. Because you don't know all the bits of a flower. The zoology, you would have no chance. You'd have to draw the parts of a worm and label and draw it pretty accurately. So that's, the subjects have actually changed, they've progressed. We haven't changed the system though. It's still 120 hours, 180 periods of 40 minutes. It's like you keep stuffing more in. It doesn't fit.
So why do you think that they haven't changed it? If they realize this isn't working, that they can't agree on it?
Well, I mean, so are you even, most people aren't even familiar with it's a problem. I'm saying, this is a problem. You're trying to put more, and I have a little demo, and I can't do it here because there's no, I have a little demo with the beaker, right? You just start out with the beaker, 250 ml beaker, and you fill it up with water. And then you bring another beaker, and you fill it up with water, and then you try and pour the full beaker into another full beaker. Guess what? It doesn't fit. Why not? It's full, right? They wrote these things in 1909 for the curriculum in 1909. Then they added stuff. It doesn't fit. So the sciences, like every other subject, should be taught over multiple years. That's my point. Like they are in every other country on the planet Earth. Makes sense.
So at the same time that this was happening
very similar to what happens over here in all of the subjects. So like French, French 1, French 2, French 3. So if a new thing comes in French, it appears in French 3 first, and then it filters its way down to French 2, and then French 1. Not in bio, in, that's it, or not in.
So the same thing over there.
Same thing over there, but they have multiple years. So the harder stuff, all the new stuff appears in the 12th grade and the 11th grade first, and then it moves down.
So even in the
Yep, multiple years. Multiple years, yeah. And the Americans also considered that originally as well. It logistically couldn't be done with small schools. So over there, it's much smaller. America is a very big country.
And it also work better just because you can like major in like a high school level.
And hey, there's disadvantages of that system. I'm 14, I'm deciding, am I going to be a scientist or am I going to be a linguist? It's a one-way street. Latin or chemistry? I kind of like both. Latin or chemistry, but I like chemistry more. So I got into the science track at 14, and then I'm going in the science track. I'm not going back. It's a one of the things. There are other things that there's no transfer over there. I mean, the idea of transfer just doesn't exist. You go to college and you've got these credits, and you bring them along to another college and you transfer them. They just laugh. No. Did you pass the exam? Yes, you've got the qualifications. When you want to go to another college and you haven't passed the exam, start again. That's it. So there's no so there's a few bad things about the system. It's very narrow. It restricts what you're going to do. And if you go the wrong way, you're in trouble. It's much more elitist. i.e., not everybody gets to go to higher ed. 15. When I was growing up, 15% went to college. Here it's 65, 3 or 4 times as much. It's kind of equalised out a bit more in recent years, but there's definitely much more of a sort of class system there as well. You have to pass exams. Well, kids who are, financially viable parents do better than kids who are poor. So you definitely have a concentration of, and lack of diversity in the colleges over there, because the rich people go, and, So you've got that sort of aspect to it. So there are swings and roundabouts in it, but for the sciences particularly, it's a problem. And, it's got to be dealt with. How much more? How much more are you going to put? Look at this book, is like £7 in those old units. It's like, how much more are you going to, and it's been getting bigger. And it will keep getting bigger. It's, it's just a burden on the kids.
For your high school, how many days a year do you go?
192, so it's more than over here. So there, you finish about a month later. So it usually goes, you start 10th of September or something like that, so it's a little later than here, not much. Then you go 6 weeks, and then you have a week off. Then you go 6 weeks, and you have a week off. Then you go 6 weeks, and you have a week off. 6 weeks. 6 weeks. So it kind of goes like that. And then, so you finish like 20th of July, not the 20th of June. And that's part of the American one is because of, agriculture and crops and stuff like that in various places, and there were different things adopted. But now it's, America's between 162 and 180 days, 182 days in different states. Starting age varies between 5 and 8. Science requirements in the United States, depending on the state, vary from 1 year to 4 years. Some states, most of them have got 2 and 3. 3 is actually the more common one now, but it used to be just 1 or 0. So there's lots of differences.
Believe it or not, my path was actually the opposite to yours.
Good.
I went to science, I guess in high school. I took 2 years of chemistry, 2 years of biology, 2 years of physics, 5 years of math, 7 years of health, I guess, because it was semester
Right.
on a block schedule. But I never took theater class. I took minimal English, history, language.
Right.
And it worked out for me because I'm a chemistry major now. But I don't know. I had to choose when I was 14,
Right.
these 5 vocational
Right.
schools kind of.
Right.
And I can't figure out what would be the right change to make that would double a school day or make a school day all year round.
Well, you've got to decide that. I mean, one of the issues I was just suggesting was, so how come you're treating the subjects differently? And people don't say this. You see the STEM thing, and everybody's trying to add an A to it, STEAM or STEMs. They're always trying to add those sort of things to it. And I'm saying now, presently the sciences, and not math, by the way, sciences get less time per credit than any other area of the curriculum. And most people don't recognize that. Even though it's generally considered to be the hardest area, they get the least time. So the question I was asking earlier about which one is the least time to AP, it's physics. Physics is generally considered the hardest subject, apart from calculus, right? BC calculus is considered the hardest AP. And it has actually the least time. The kids spend the least time before they get to that exam. Why? Because Long Island, the common practice is it's your first class. You take AP Chem as your AP Physics as your first science physics class. That's nuts. 50% of Long Island schools do that. So yours is a little unusual. So if you describe your education to most Americans, they would say, "Wow, that's unusual." They run. Oh, you went to a magnet school, right? And I think that's why not? You should be doing things you're interested in rather than doing things that you're forced into.
I don't know anything.
Right.
That can't be what you're suggesting everyone does either.
No, it's not. But I think everybody should be exposed to things, and then you do have to have a certain amount of choice. But presently, I'm in New York. Everybody's got to do 4 years of history in high school. Who decided that? You have to pass 5 Regents exams, 2 of them are history. Why? Who decided that? You have to pass 1 science. And nearly always it's not biology anymore because they stopped teaching bio and they have this thing called living environment, which on Long Island most 8th graders take and pass easily. And all the people I'm in the biochem department, all the biochem professors just roll their eyes. They think they're ready to take college bio when they've taken an 8th grade living environment course. So they're not, of course, ready to take, because they haven't actually taken chemistry. So, there has to be some sort of balance, but I think, English is the same. You can pass AP English in the 10th grade, but you still got to do it in 11th and 12th grade. Why? My son ended up in the 12th grade. He had 2 requirements left to graduate. He had to get his 22 Carnegie units, and 2 of them were only offered in the 12th grade. English, because you had to take a year each year. There's no doubling up on English in any one year, so he's stuck. Phys Ed. He needed half a credit of Phys Ed. So, there he was. He'd passed his 5 AP histories and whatever. He was all happy, but so he decided, which subjects am I going to take? He looked at the timetable and said, well, what's offered in the afternoon? That was his criteria for what he was going to take. What's offered in the afternoon? I don't have to get to school in the morning. What's the point, Because he'd accumulated his credits. He was capable of passing tests and stuff like that. I don't have a particularly good system. So yeah, there has to be a bit of choice, but sciences presently are completely and utterly undervalued in terms of the amount of time you spend to get the credits you get. You've all gone through college degrees. Oh, give me more! Give me more! I mean, that's what happens, you spend more time to get the same credits as everybody else. Why? They're the hardest subjects. They require the most intense study. They're the ones that people can't do. So the system does need to actually change, I think. Science should be more valued. Sorry, no.
Is there something now, like the Committee of 10 kind of thing, that's trying to push for... We sit here and talk about all these professional groups and research groups that are saying we need to bring science more to the forefront. Is there an active group right now?
There is not, and I'm glad you brought that point up, because it is one of the underlying things of why it's so difficult to change. The United States does not have national curriculum. Other countries have national curriculum. Now, often it's portrayed by politicians as, socialist, whatever, but largely, like in England, it's not the government that controls the national curriculum, it's the universities. It's in their interests for high standards. It's not in the it sort of is the government's version, but The universities write the exams. The universities, the government fundamentally pays for it, but the universities are autonomous from the government on those sort of issues. So you can't set it up that way. America has local control. That means, New York State has, believe it or not, 670 school districts, all of which are autonomous. There's the state standards, there's the state requirements, there's the state certification for teachers, but they can raise money, do whatever they want, teach whatever they want, provided it meets the minimum standards. And they do. Long Island has 125 school districts. That's just Nassau and Suffolk. Doesn't include Brooklyn and Queens, which are on Long Island as well, but they're in the city. They have 125 superintendents. And the average superintendent there earns 150,000. Top one earns $500,000. It's like, wow, how much money are you spending on administration there? Vast amounts, is it?
Jersey has over 66 districts.
Yeah. Right.
There are many districts in Jersey that are only one school building.
Right.
And it's an entire district.
Right.
With all the administrative functions.
Exactly. So that's an issue that goes to local control of things, and it's a fundamentally American thing, and it goes to the funding. The federal government, despite this thing called Race to the Top, provides less than 10% of funding for education. The state provides, it varies, but about half. The rest is local. And, elections are big things. So that's really an important issue when you're actually looking at that. Just to be a little controversial, just the word evolution. Throw that in there, and how is it possible that there are still districts trying to ban its teaching? Every scientific society has said evolution is what you should be taught. All states have that in, and every 2 years there's a court case making its way through where people deny the science. Interesting enough, there is no such thing as climate change. All these, it's like amazing. That's a function of local control. If it was a state control, it wouldn't happen, or if it was a national control, it wouldn't happen. So there's no committee of 10 because it would be an uproar immediately, because they'd say you're trying to impose federal restrictions upon us. My solution to it would be, who should be controlling chemistry? American Chemical Society should say, these are the requirements for a high school chem class. And if it's not that, we won't accept it. Well, change it immediately. Will the American Chemical Society do that? No. They should. They could. The willpower, money. They've probably got enough money. They're rich, so it takes a bit of willpower and stuff like that. So you guys are going to go out there, and this is what you're going to do. You're going to talk to the boards of education. You're going to be educating people in these issues. You're going to be advocates for more science, more valued science, more fair treatment. This is unfair treatment, which and people just accept it. Lab work, I was talking about lab work, that's kind of where that's where it actually comes out. So I think it's really quite important.
You talked about that you're like a believer in physics first. Do you know how did it...
I'm not. I am not. If you look, I have lots of articles on physics first. I'm a believer in physics for all. I think if you're going to live in a modern society, you need to have some physics. Now, I would suggest that could be conceptual physics. It could be state level physics, like Regents physics. It could be AP physics. It could be whatever level you want. But you should have some. We're going to mandate you have 4 years of history. We're going to mandate you have 4 years of English. But we're not going to mandate you have any physics in this present world. So the statistic at the moment is 37% of United States high school kids leave with the physics. If you look at the colleges, 50% of kids go to college have taken physics. Majoring in science, 80% of kids majoring in science have taken physics. It's a bellwether of the health of the things. So I am actually not in favour of physics first if you're going to take the 12th grade physics class and teach it to 9th graders. That's a recipe for complete and utter disaster. It's the old system. Oh, here's the book. Let's give it the 9th grader. And 9th graders actually do better than the 12th graders on it, because the 12th graders have had 4 years of carrying these heavy science books and have got sick of it and have got into college. So 9th graders do a little better, as it turns out. But can you teach physics to 9th graders? Yes. Which countries in the world do it? Every other country in the world teaches 9th grade physics. There is no debate about physics first elsewhere.
So do you know how like America came up with their biology?
Because the 1-year courses. That's it. So you've got to be in an order. So I didn't give you, I'll grab Brian, I'll send you the article on that very question. I wrote the article on it. Dennis did his dissertation on it. It comes out, the Committee of 10 said physics should be first. There were only 2 subjects around at the time, physics and chem, and then there's botany and zoology, which kind of aren't in the mix. So what happens is botany and zoology coalesce and become biology. Physics is actually first. In 1900, most people graduated with physics, more than chemistry or botany or zoology. So physics was first. And that's the article's actually called Physics Was Once First and Was Once For All. And then what happened was the physicists wanted to have the physics taught closer to college because the dropout rate was incredible in the 1900s. 100% of kids starting the 9th grade, 10th grade is down to 70, 50, 30. So the physicists figured, we want the smart kids, we want the 12th grade. So they actually petitioned, and they were the powerful group in the schools at the time. So they got their wish, and chemistry moved before them. Biology was written to be a 10th grade course, and it became a 10th grade course in like 1990. New York's the first place really to have a general bio class. And interesting aside, it was written at, and this is the power of teachers, the first general bio class was taught at DeWitt Clinton High School in New York City. And that school had, and the school still exists in New York, but it actually moved to the Bronx. That school had 4 or 5 bio teachers there who between them had an 82% share of the market of physics, biology books in the country. One school. And one of them is very famous, although you probably don't know him, George W. Hunter. Ever familiar with George W. Hunter? Scopes trial? Scopes trial, the monkey trial, where they were protesting that Scopes had actually taught evolution. Well, that's not what it says. It says Scopes is guilty of teaching Hunter's biology. Hunter was a biology teacher in New York City who had written the book Elements of Bio, which has 4 pages on evolution in it, and Scopes was teaching those 4 pages. Other books didn't have it in, by the way. So it's Scopes, it's Hunter's biology, and it was a New York City book being taught in Tennessee. Go figure. Because Tennessee adopted the book. The whole state adopted the book, and it had these 4 pages on evolution. And the Butler law said it's illegal to teach it. So Scopes taught it, and he was a phys ed teacher. He wasn't a bio teacher. They set him up to do it. So, but that shows you, how the sort of thing works. So bio becomes a subject. 1910 or so. 1913 is the first College Board bio exam. 5 kids take it. By 1929, it's dominant. It's taken over, and it becomes the 10th grade class. So it used to be geography, physical geography, biology. Well, actually, it really was physical geography, biology, and physics. Actually, sort of vied it to each other till about 1930, and then chemistry was always last. And then by the 1930s, though, the physicists had gone to the end, the biologists had gone in the 10th grade, the physical geography had disappeared, and general science had gone in. So by 1930s, it's bio, chem, physics, and then remained it thereafter.
You were talking about last week about it's interesting the sequence because to really understand biology, you have to understand chemistry.
But not then. But not then. Biology.
At least now, it just doesn't make
Right.
sense. They're learning about
Exactly.
and all these reactions. They don't even know what a chemical reaction is.
Exactly, and what I was saying was the curriculum unit was set up before half the bio was. There was no. If you look at a bio, I didn't bring bio books, but if you look at a bio book from you can look at all of these are available through Google Scholar, Google Books. Just go on, type in George W. Hunter, and look what comes civic biology. There's no chemistry in it at all. There's all about diseases, health. There's all about there's some pretty scary things in it as well. There's we shouldn't be letting, there's eugenics in there. We shouldn't be letting these families breed, because they're mentally deficient and they can pass that on. And they've got little charts showing the passing on of mental deficiency. Completely fiction, of course. And bumps on their heads and stuff like that. So there's all that stuff actually in there. All the original genetic stuff is in there. But there's no chemistry in it. And a lot of the stuff originally it's basically morphology of plants and animals and generally categorization and then drawing. So that's the biology they originally had. It's only in the 50s it becomes...
Changed it.
Yeah, no, but the curriculum time, it's very difficult to do. So they came up with that in like 1914 or so, and they were saying you should do this general bio class and a bio class. They were saying 2 years, should be 2 years, even in the 1914s. So, but it didn't happen. So now everybody teaches bio first. Pointless, really pointless now, because it's got a chemical basis. And we changed everything to have a chemical basis. And then the physics, the physicists shot themselves in the foot, and they still continue to do that. I don't do 9th graders. They made it very mathematical. It was a self-fulfilling prophecy. You saw the Committee of 10 table? There was no pre-calc or calculus, and they were still recommending physics first. You can teach physics without calculus. In fact, virtually every high school in the country does. There's only AP Physics C that has any calculus in it. So you can teach it, but hey, it's much easier teaching 10 kids in the 12th grade than it is teaching 250 in the 9th grade who are going to ask questions and stuff like that. So, right.
Question. With the changing of the AP curricula over the next handful of years, as they've announced, how is that going to impact?
All right, I think the best thing I've seen, and I'd like to be positive in this, AP Physics B is a 2-year course. They just said it's a 2-year course. So what do you think all the schools on Long Island are doing? Plotting how to make it a 1-year course. And the College Board will probably capitulate. But if the College Board says, and you've got to take at the end of your first year this part 1 of the exam, and the end of the second year part 2 of the exam, they've won. It's a 2-year course. It's a 2-year course. Minimal. I'd say 3. I'd go for 3. Ain't gonna happen. But
my understanding, at least with the AP Bio, is that the test is now going to be partially hands-on.
Good.
Like lab stuff.
Yeah, fine. Yes, I did do A-levels. Yes, they had a practical component. 5 papers I took. And they were a multiple choice, a data analysis, they gave you data and you had to analyse it, essay, structured questions, and a practical exam, which took 3 hours. Very expensive way of doing it, but you're majoring though. I'm only taking 11th and 12th grade, math, physics, chem. No distributed education requirement here. I'd matriculate, I'd passed the English test, and that was it. I was quite happy. So it was, the more science you can get in the curriculum, the better. And I am not suggesting we add more science. I'm just suggesting we add more time to what we're already doing. That's it.
There's benefits to schools that have like a general science, like physical science in the freshman year.
Yeah. If it means you're getting exposed to that, great. One condition I'm going to point out though, you've got to have people who can teach physical science. New York, 90% of teachers teaching 7th and 8th grade are biologists who do not often teach physical science. So I've worked with school districts, I'm not going to mention them, and we do day 1 curriculum map. And we take, here's the syllabus 5 through 8, here's the topics, who's doing this, and rock cycle. The rock cycle's taught in the 6th, 7th and 8th grade. I'm doing it. I'm doing it. I'm doing it. They're all doing it because they all like to do the rock cycle. All the plant stuff gets done multiple times. Who's doing the motion and forces? Oh, that's in the 8th grade. Oh, that's in the 7th grade. Oh, that's in the 6th grade. Nobody's doing it. So you just look at the exam results. You can, in New York, they give you an analysis of the questions. The physics questions score the lowest. I mean, this stuff is really simple. It's like moving, 2 feet a second, how far are you going in 3 seconds? 6, and that's it. There's nothing read this graph. It's nothing really complicated. But they score lowest on that.
Do you think it's a function of looking back to 2010? Whoever had the loudest, most persuasive voice had their concepts included in the curriculum?
There's a touch of that. But I would say it's presently the reverse. What's happening now is that the science people don't have a voice. And here's my illustration. I work in Suffolk County. There are 69 districts in Suffolk County, 56 of which have high schools in them. Of the 69 superintendents, 4 of them have science qualifications. 23 of them have elementary qualifications. 16 have social studies qualifications. Sciences are just not represented at all in the administration. So who's giving them the advice on what science to take? One of the school districts, when there was a budget crisis 2 years ago, said, if the budget fails, physics goes. That was their cost-cutting measure. Because it's expensive, all those equipment, and it's the smallest classes, because we teach it badly, that was their solution. Well, fortunately, the budget passed, but that's what you're dealing with. So I think it's the reverse. I think the scientists need to be out there more active by it. You all should be pressing the Kean University administration to give more credit for science, or the equivalent amount of credit for the time. This mythology that you're out there reading books and that counts the equivalent is exactly that. Mythology, you guys are reading books, you're studying harder things, and they keep lobbing more on you. So, particularly if you're chemists. My education was full-time, I remember that. And I had a criminologist. He had 5 lectures over a 2-week period. Some days he didn't get up. He didn't have classes. I had lab every day. It's like, where's the fairness in that? Okay. So, Brian, I will send you the article on the sequence and where it came from. And it's quite interesting.
Questions in general about science education and everything I know, he knows just a stage a little more about than I do.